will present for the construction of parallel high voltage measurement using FC and picoscope. Firstly, there is a computer which has been connected to the frequency converter by using Internet Ethernet cable and picoscope for certain condition or activity. The blue box is the picoscope. Picoscope has 4 channels that are from generation, measuring section for handling control unit inside the control room. Short coaxial cable of 40 cm connected from the termination of 100 picofarad capacitor to the adapter A. Then the adapter A is connected to the secondary unit of AC followed by the adapter B. BNC T junction is then connected at the adapter B. Long coaxial cable X is connected from the one side of the T junction to the frequency converter VM1, while the other side of the T junction connects the long coaxial cable Y to the picoscope. After the connection is complete, remember to double check and by making a little pulling test to ensure that the connection have plugged in proper manner. GND is the grounding. It must be ensured that the ear part has to be connected to the body of the enclosure, which the enclosure connected to the grounding brake cable. Remember to ensure that the earthing switch had touched the capacitor properly. The connection cable must be cleaned properly by placing them neatly. Ensure that every time when we get inside the testing plan, we must use special glove, which is a rubber glove, before touching. Reduce the voltage of generator for safety when touching around the high tension and high stress perception. For double saver, we can do discharge by using grounding rod to touch the surrounding of measuring cap for discharging. Remember to hold the end at the end of the grounding rod.
Next, I will explain for primary side of the transformer progress. The figure shows the primary side of transformer progress. Source voltage does not maintain due to effect from background noise. When pressed the highest 10 volt of source control, primary side at 11 kV show that voltage of 46.59 volts and current of 170.59 milliampere. Next, measured 3 refer to VM3, measured 4 refer to VM4, measured 5 refer to measured 5, VM5 and measured 6 refer to VM6. Now I will explain for alarm system. Based on the figure on the left show a red alarm that indicate that there is some problem before we can start do the injection in this experiment. When the alarm show red color, we cannot do any injection because of safety purpose. In this lab, interlock have connection with latching sensor, so when we did not close the door properly, sensor does not close and the alarm will show red color. Therefore, we must close the door properly so that the alarm will show the green color and we can do the injection safely. In this software, we can find out the problem more quickly because the screen on the right shows the problem when the alarm is red. After solving the problem, click on the reset button to clear the problem and the alarm will turn to the green color. Assalamualaikum warahmatullahi wabarakatuh. My name is Siti Rasimah binti Jamal. Now I will present my part for section 2. First, I will explain for source control. The figure shows a device for Picoscope 3000 series PC. The Picoscope 3000 series PC oscilloscope are small, light and portable, while offering the performance specification required by user in the lab. The oscilloscope offers 4 analog channels. In this lab, all the channels connected to the generator. This device is placed in control room for safety purpose. Next, this device will produce analog signal that come from frequency converter that will be set in this lab. The important setting in picoscope is excitation system that set from 0 until 1000 K. The sample point has been set at highest, which is 1000 K, because the shape will be better and more sufficient visualized monitoring. Next, for sampling interval we set at 10 micro. Basically, in this software have 4 channels, which is A, B, C and D, because on this device picoscope also have channel A, B, C and D. After that, we must make sure that coupling will be set at AC. The range has been set on 10 volt. This software also has been set divider ratio is 19651.1. So, the figures show that have 4 button control on this system. Firstly, press the button, power button, to connect this software to FC. Then press ready button to do the injection. During this time, the color of lamp changed from green color to red color. It showed that particular the reading was active. It in open condition. So in this situation, nobody allowed to be in the testing place for safely. When HV is on,
Okay, now I will present on section 3. First, we will compare the result between the reference, kit control and display value, that is the picoscope. So, the output voltage we can calibrate in percentage, that is from 0 to 68.7. And the first table showing the reference RMS and the display RMS, while there is a frequency, nominal frequency we set to 50 Hertz. Okay, the second table is we have take a reference peak over square root 2 value and display peak over square root value, and the same goes to the frequency. It is set to 50 Hertz. Actually this both value can get in one same screen, but I have insert them in different tables. Okay, so the next we will calculate the percentage of error between the values. I have calculated the error difference between the reference RMS and the display RMS. So for the first, reading has been taken while compared with the reference value. The RMS value has been taken to do the comparison. When the output voltage is 0%, the reference RMS is 533.753 volt. The display value is 946.07 volt, while the percentage error is negative 77.25%. When the output voltage is 4.3%, the reference RMS is 5.008 kV. The display value is 4.55 kV, while the percentage error is 9.14%. When the output voltage is 10%, the reference RMS is 11.809 kV. The display value is 10.87 kV, while the percentage error is negative 7.95%. So when the output voltage is 17%, the reference RMS is 19.611 kV. The display value is 18.60 kV, while the percentage error is 5.16%. Okay, now when the output voltage is 26.5%, the reference RMS is 30.20 kV and the display value is 28.98 kV and the percentage error is 4.04%. When the output voltage is 33%, the reference RMS is 35.048 kV, the display value is 34.97 kV, while the percentage error is 0.22%. When the output voltage is 38.7%, the reference RMS is 40.331 kV, the display value is 40.51 kV, while the percentage error is negative 0.44. Okay, when the output voltage is 58.7%, the reference RMS is 61.484 kV. The display value is 60.91 kV while the percentage error is 0.93%. When the output voltage is 68.7, the reference RMS becomes 72.961 kV and the display value is 70.74 kV while the percentage error is 1.70%. The output voltage is adjusted, and when the output voltage increases from 0 to 68.7%, the reference value of RMS also increase exclude for the output voltage of 0%. The display value of RMS also increased. The percentage error for the output voltage is not steady for sometimes. The error is lesser than it goes up and sometimes it is in negative value. The percentage of error maybe comes from the machinery error or the calibration error. These types of technical errors can cause the reading to not get an accurate value. To obtain an accurate value, user must take readings many times and take the average from it. The value of peak over square root of 2 is not used for calculation since the value of reference and the value of display is totally far different and also the error is very large. This might be the cause of source voltage which is not constant, so the waveform produced is not achieving the same value as the reference value. On the other hand, the major factor might be if there is some heat factor in the system, then it tends to interrupt the readings obtained. So for the conclusion part, the coupling setting should be set in alternating current, which means activating the AC coupling since we will be taking the waveform of alternating current. On the other hand, the range if scope is not advisable to be set using automatic range for the beginners. We are advisable to use our own range option given. We can use 100 mV to 200 mV, which is a very small value of voltage compared to 1 volt or 2 volt. This is to enable the user to obtain a better amplitude waveform with a better scale and value. On the other hand, if the range is set to 1 volt, then we can obtain the amplitude reading from 0 volt to 1 volt of amplitude, which will not give an accurate waveform as detailed as the 100 mV amplitude. On the other hand, for the acquisition settings, which is the number of sampling, should be set from 0 to 100 K sampling, which is the highest value. This represent the 100K sampling represent that one period of time have 100K kilo points of discrete sample. The higher the value of the sampling point, then it will give a better waveform output. The waveform also taken by increasing the percentage of output voltage. So from the increment, two values have been obtained, that is the value of RMS and peak over square root 2. From there we have compared with the reference value and also have found out the error percentage to see the difference between the reference value and the display value. Thank you.